Good day, everyone. I am Master Ryan. Merritt Education Center would like to present to you Mathematics for Active Learning for P.6. We will talk about prime factorization. Let's get started with our lesson. In this lesson, you will be able to identify prime numbers and find the prime factors of a number using the factor tree method and the repeated short division method. There are 24 spaceships and 18 space shuttles that need to land on the 6 landing pods of these space stations. How many spaceships and space shuttles will there be on each landing pod if they are divided equally among the space pods? To answer these questions, we will learn about factors. Before we proceed, let's have a review about prime numbers. Is 43 a prime number? Let's analyze. Is 43 an even number? 43 is not an even number. So 2, 4, 6, 8, and 10 are not factors of 43. Next, what number can you multiply 3 so you can get 43? You're right! There is no number to multiply 3 to get 43. So, 3 is not a factor of 43. Is there a 0 or 5 in the ones place of 43? Definitely! There is no 0 or 5 in the ones place of 43. So 5 and 10 are not factors. Can you think of a number to multiply 7 to get 43? Yes, you're right. There is no number to multiply 7 to get 43. 7 times 6 is equal to 42 and not 43. How about 9? Is there a number to multiply 9 to get 43? You're right again. There is no number to multiply 9 to get 43. 9 times 5 equals 45 and not 43. So, the 7 and 9 are not factors of 43. That leaves 1 and 43 as the only factors of 43. So, 43 is a prime number. Did you get it right? You're smart! How many boxes are there? Yes, you're right. There are 7 boxes. What are the factors of 7? What numbers can you divide 7? Yes, you're right again. The factors of 7 are 1 and 7. The numbers that can divide 7 are also 1 and 7. So, 7 is a prime number. Now, let's proceed to prime factors. Let's find the prime factors of 6. Let's enumerate first the factors of 6. Yes, you're right. It is 1 times 6. Are there any more factors of 6 you have in mind? You're fast. It is 2 times 3. Do you think there are any more factors of 6? There are only 2 sets of factors of 6. It's 1 times 6 and 2 times 3. Among 1, 2, 3, and 6, which are prime numbers? 2 and 3 are prime factors of 6. Did you get the correct answer? Good job! Let's have the last example for prime factors. Let's find the prime factors of 187. Let's enumerate first the factors of 187. Yes, you're right. It is 11 times 17. Are there any more factors of 187 you have in mind? There is only one set of factors of 187. It's 11 times 17. Among 11 and 17, which are prime numbers? You are clever! 11 and 17 are prime factors of 187. Did you get the correct answer? You are amazing! We are going to find the prime factors of 48 using factor tree method. What are the factors of 48? You're fast! It's 6 and 8. Now, are 6 and 8 prime numbers? You're right! 6 and 8 are not prime numbers. So let's continue factoring 6 and 8. What are the factors of 6? It is 3 and 2. Are 3 and 2 prime numbers? You're fast! We now have prime factors for 6. How about 8? What are its factors? It is 4 and 2. Are 4 and 2 prime numbers? Among 4 and 2, which is a prime number? It is 2. So, let's proceed to factor out 4. The factors of 4 are 2 times 2. So now, the prime factors of 48 are 3 times 2 times 2 times 2 times 2, or it can be represented by the index notation 2 to the power of 4 times 3. Let's have another example using the factor tree method. We are going to find the prime factors of 189 using factor tree method. What are the factors of 189? You're fast! It's 7 and 27. Now, are 7 and 27 prime numbers? You're right! 7 is a prime number, while 27 is not. So, let's continue factoring 27. What are the factors of 27? It is 9 and 3. Are 9 and 3 prime numbers? 3 is a prime number, while 9 is not. Let's continue factoring out 9. What are the factors of 9? It is 3 times 3. 3 is a prime number. So now, the prime factors of 189 are 7 times 3 times 3 times 3, or it can be represented by the index notation 3 to the power of 3 times 7. How do you find the factor tree method? Is it easy? You are fantastic! Let us do another method of finding the prime factors of 48. We will use the repeated short division. What prime number do you want to divide 48? So, let us divide 48 by 2. What is 48 divided by 2? You're quick! 48 divided by 2 is equal to 24. Is 24 a prime number? 24 is not a prime number, so we need to continue factoring out 24. What is 24 divided by 2? You're right! 24 divided by 2 is 12. Is 12 a prime number? 12 is not a prime number, so let's continue factoring out 12. What is 12 divided by 2? That's fast! 12 divided by 2 is 6. Is 6 a prime number? 6 is not a prime number, so we will continue factoring out 6. What is 6 divided by 2? 6 divided by 2 is 3. Is 3 a prime number? 3 is a prime number. So, the prime factors of 48 are 2 times 2 times 2 times 2 times 3, or it can be represented by the index notation 2 to the power of 4 times 3. Let us proceed to another example using repeated short division. What prime number do you want to divide 189? Did you say 7? So, let us divide 189 by 7. What is 189 divided by 7? Brilliant! 189 divided by 7 is equal to 27. Is 27 a prime number? 27 is not a prime number. So, we need to continue factoring out 27. What prime number can you divide 27? Did you say 3? What is 27 divided by 3? You're right! 27 divided by 3 is 9. Is 9 a prime number? 9 is not a prime number. So let's continue factoring out 9. What prime number can you divide 9? 9 can be divided by 3. What is 9 divided by 3? That's fast! 9 divided by 3 is 3. Is 3 a prime number? 3 is a prime number. So, the prime factors of 189 are 3 times 3 times 3 times 7, or it can be represented by the index notation 3 to the power of 3 times 7. Find the prime factors of 64 using the factor tree method. Now, let us discuss our answers. The factors of 64 are 8 and 8. That was fast. 8 is not a prime number, so we will factor out 8. The factors of 8 are 4 times 2. 4 is not a prime number, so we will factor out 4. The factors of 4 are 2 times 2. 2 is a prime number, so the prime factors are 2 times 2 times 2 times 2 times 2 times 2, or it can be represented by the index notation 2 to the power of 6. Did you get the correct answer? Fantastic! This time, let us try to find the prime factors of 288 using the repeated short division. So, let's discuss our answers. 288 divided by 2 is 144. 144 is not a prime number, so let us factor out 144. What prime number can divide 144? That's fast! 2 can divide 144. So, 144 divided by 2 is 72. 72 can still be factored out. So, 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 is a prime number. So, the prime factors of 288 are 2 times 2 times 2 times 2 times 2 times 3 times 3, and it can be represented by the index notation 2 to the power of 5 times 3 to the power of 2. Did you get the correct answer? Job well done! Which method do you find easier to find prime factors of numbers? Is it factor tree method or repeated short division method? Now that we already know how to find the prime factors of numbers, let us answer the previous question. There are 24 spaceships and 18 space shuttles that need to land on the 6 landing pods of the space stations. How many spaceships and space shuttles will there be on each landing pod if they are divided equally among the space pods? What do you think are we going to do? We will divide 6 to 24 and 18 so we can obtain the number of spaceships and space shuttles. So, 24 divided by 6 is equal to 4. 18 divided by 6 is equal to 3. So, there are 4 spaceships and 3 space shuttles on each landing pod. Please take note about the following concepts. A prime number has only 2 factors, 1 and itself. A prime factor is a factor which is a prime number. Expressing numbers as products of their prime factors is called prime factorization. Prime factorization can be done using factor tree method and repeated short division. Express the factors in index notation if necessary. Hope you have fun learning today. See you in the next episodes.